Welcome dear students. In today's class we start the discussion of module 4 of organic chemistry, that is lipids, steroids, vitamins and hormones. So this module deals with 4 important biomolecules, namely lipids, steroids, vitamins and hormones. Today we start the discussion of lipids first. The term lipid comes from the Greek word lipos, means fat. So lipids are waxy, fatty, oily substances which are naturally occurring compounds present in living organisms, and they are generally esters of long chain carboxylic acid and alcohol. The main feature of lipids are that they are insoluble in water and soluble in organic solvents like ether, chloroform, etc. It is because they are highly non-polar in nature. If you look into the structure of lipids, we can see that they contain mostly carbon-carbon bond and carbon-hydrogen bond, and there are only very few functional groups or polar groups. That's why they are insoluble in water, unlike other biomolecules like carbohydrate, protein, nucleic acid, etc., which contain a good number of polar functional groups. Now we first discuss the classification of lipids here. Lipids are broadly divided into 3 main classes: simple lipid or homolipid, compound lipid or complex lipid, and derived lipid. These are the 3 main classes. What about simple lipid? They are again of 2 types. Simple lipids are those lipids which on hydrolysis give only 2 products. One will be a fatty acid and the other will be an alcohol. See that lipids are mostly, generally, esters of carboxylic acid and alcohol. If on hydrolysis lipids give only carboxylic acid and alcohol, nothing else, then they are called simple lipid or homolipid. Whereas in compound lipid, which on hydrolysis gives, in addition to carboxylic acid and alcohol, they will give some other compounds also. If you look at the examples, you can understand that phospholipid, which contain a lipid part that consists of carboxylic acid and alcohol, and in addition there is a phosphoric acid group also. So that means lipid plus phosphate group. Glycolipid is lipid plus carbohydrate. Lipoprotein is lipid plus protein molecule or protein entity or amino acid, like that. So that's compound lipid. So on hydrolysis, the lipid part will be giving alcohol and carboxylic acid, and in addition it will give one more group, a biomolecule. Now coming to derived lipid, all compounds derived from or obtained by hydrolysis of simple and compound lipids. That's why the name derived. So these are derived from simple and compound lipids. And this class is very wide. It includes many different types of compounds like fatty acid and fatty alcohol, of course. See, fatty indicate long chain hydrocarbon, long carbon chain which is unbranched, that is fatty. Okay. So if you hydrolyze simple lipid, of course you will be getting fatty acid, that's the carboxylic acid, long carbon chain, and fatty alcohol will be there. It also includes, in addition to this, steroids, which is a different class of compounds like cholesterol, for example. And there are so many sex hormones which are also having the basic structure of cholesterol. Then some vitamins which are fat soluble like vitamin A, D, E, K. These also are included under, there are lipids. And also another class of compounds that is obtained from plants which are called essential oils like eucalyptus oil, lemongrass oil, etc., which are generally called terpenes. All these come under this derived lipids. Now let us elaborate on a few of them. According to our syllabus, we have to discuss in detail about triglycerides, number 1, then on wax, number 2, then we have to emphasize phospholipid, number 3, and then we have steroids to discuss in detail, number 4, and we have to discuss about vitamins, and of course terpenes come in another module. In addition, you can see we also discuss about hormones which are basically related to steroids. Okay, so coming to the first one, simple lipid. So this is made up of a carboxylic acid and an alcohol form an ester. So simple lipids are esters of fatty acid, that means long chain carboxylic acid with alcohol. Okay, you know ester is made up of carboxylic acid and alcohol. Now it is divided into 2 types. What is the difference here? In triglycerides, the alcohol part is glycerol. You know glycerol? Glycerol is CH2OH, CHOH and CH2OH. Means it is a trialcohol, triol, 3 OH groups. And fatty acids are combining with this, forming esters. So naturally it will be a triester, or it is a triglyceride. Why we call tri? Because there are 3 ester groups. And this R1, R2, R3. So this glycerol is combining with carboxylic acid. Okay. Like this. And if you eliminate water, you will be getting this group, ester group. So like that, 3 carboxylic acids or fatty acids are connected, forming a triester. So this is triglyceride. We can also call it, this can be called acyl group. So triacyl glycerol, that's another name for triglyceride. Whereas in wax, this is the general formula for wax. This is the general formula for triglycerides. Here RCOOR dash, where this R is a long carbon chain fatty carboxylic acid or fatty acid, and R dash is also a fatty alcohol, a long chain alcohol. So wax is a monoester, whereas this is a triester. That's the difference. And number 2 is that the alcohol part here is glycerol, whereas the alcohol part here is a fatty alcohol. Putting an example for wax, for example, we can say myricyl palmitate, that is C15H31 COO. It is C30 H61. So this is called myricyl. This is palmitic acid, one of the fatty acid. So this is called myricyl palmitate. Okay, that's an example for a wax, and this is actually beeswax produced by bees, which is used for making their honeycomb. And waxes have a lot of application that we'll discuss later in a different section. Okay, now coming back to this triglyceride, we will discuss on wax later, phospholipid also in detail later. We will discuss more about this triglycerides. Listen, triglycerides are again of two types, fat and oil. We generally use these fats and oils. Fats are basically solid and oils are liquid. And you know, these lipids are obtained from not only plants but also animals. We get it from plants as well as animals. So what's the difference between fats and oil? And remember, wax is also a solid form of lipid, right? Waxes are solids. Now coming to this fats and oils, see, in this triglyceride, what differ is this R, okay? So let us understand more about this fatty acids. What are the fatty acids possible in triglycerides? See, if this, okay, let me put example for these fatty acids. Fatty acids can be either saturated or unsaturated, right? Let me write a few of them. Generally, fatty acids contain even number of carbon atoms, and the number of carbon may range from C12 to 20 or sometimes 22, like that. Putting examples, a few of them. C15H31COOH. Okay, this is called palmitic acid. This is called palmitic acid, right? I am putting a few only examples. Another one, C17H35COOH. This is called stearic acid. Stearic acid. Okay. If we write the next one, it is in the homolog series. If C19, then H will be 39 COH. That's called stearic acid. That's called linoleic acid, and it goes like that. Okay, not linoleic acid, it is arachidic acid. Coming to unsaturated, see, in this stearic acid there is C17H35. So remember, see, look at this hydrocarbon part. This is saturated, right? Alkane type. CnH2n plus 2 type. See, C17H35 and COH. So it is fully saturated. There is no double bond. But if we keep a double bond, so number of hydrogen will be 2 less. So it is C17H33 COH. Okay? See? 2 hydrogen less, so there will be 1 double bond. This is known as oleic acid. So this is an unsaturated fatty acid. So fatty acids present in this triglyceride may be saturated or unsaturated. These are saturated ones. This is unsaturated. See, I am writing another unsaturated fatty acid. See, again the same number of carbon, C17, but one more double bond. Remember, in oleic acid, double bond appear at C9 carbon. So the second unsaturated fatty acid is C17H31COOH. That means compared to oleic acid, 2 more hydrogen less. That means there is 1 more double bond. Okay. In oleic acid, there is, you can see it's coming from stearic acid, C17H35, 2 hydrogen less, so it has 1 double bond, and that is at C9. Okay, double bond is at C9, so it's between C9 and C10. Starting from this carboxylic acid carbon, which is having priority, which is numbered as 1. Okay, now in the second one, linoleic acid, you can see 2 more hydrogen less, so there are 2 double bonds, and it is at C9 and C12. Okay, right. So in triglycerides, the fatty acids could be either saturated or unsaturated. Now coming to the two category of triglyceride, that is fat and oil, what's the difference? In fat, fat is solid and oil is liquid. Remember, in fat, the fatty acid is mostly saturated. Saturated fatty acids are present. Okay? Not all. See, triglycerides are again divided into two types. In another way, triglycerides are divided into two types in another way. It's based on whether this R group is same or not. If all R groups are same, then they are called simple triglycerides, right? Simple triglycerides. If these are different, then it's called mixed triglyceride. Let me put an example. See, I'm writing an example. Look at this. CH2O CO C15H31. CHO CO C15H31. CH2O CO C15H31. You can see that the R group is one and the same, and it is actually coming from which one? Palmitic acid. So all carboxylic acids are palmitic acids. So it's a triglyceride of palmitic acid, which is systematically called, the name is given like this, it is called tripalmitin. This is called tripalmitin. So this is a simple triglyceride. Whereas generally it is that these are found to be different. That means it's mixed. For example, if I'm changing it here like this, suppose this is C17, H35. That means stearic acid part is this, and this is palmitic acid. This, let me change C17, H33. That means it is oleic acid moiety. So how you name this one? So this is a mixed triglyceride. So it's numbered like this. This is alpha, this is beta, and this is alpha dash, because these are identical positions. Okay, equivalent. So this is named like this. That is alpha. This is what? Oleic acid. So alpha oleo. Then beta, which one? It is palmitic acid. So beta palmito. Okay. And finally alpha dash. The name ends with IN. And what is this one? This is stearic acid. So stearine. Alpha dash stearine. That's how the name. Anyway, these are the two types of triglycerides in another way of classification. So coming back, see, this R group can be same or different. If this R group is more of saturated, then it is called fat. And if it is more of unsaturated, fatty acid is present in the triglyceride, it is coming under the category of oil. Now naturally comes a question, why it is so? Why it becomes liquid if it is unsaturated, and why it becomes solid if it is saturated? The answer is simple. If R group is saturated, fully saturated, then this R group, the fatty, the long carbon chain of fatty acid will be having this configuration as zigzag chain, and it will fit closely in the lattice, right? In solid state, it will be more efficient packing if it is a zigzag chain. and eventually attraction will be more and it will be a solid. That's why. Whereas in the case of oil, where there is unsaturation, right, that means there is double bond. So when there is double bond, it will have geometrical isomerism, and it is found that the configuration is found to be, it is found to be cis. Okay, and so it will have cis configuration like this. Okay, and due to this cis configuration of the fatty acid part, the packing will be poor. They may not fit into the lattice closely. So packing efficiency is less and molecules will be not very close, attraction will be weak, and they will be eventually liquid. So that's why oils are found to be liquid. And generally what we do is we convert oils into solid fat by hydrogenation reaction that we discuss later. Hydrogenation of oils. By adding hydrogen in presence of catalyst, the double bonds are broken and it becomes saturated. Okay, that we'll discuss later. So that's about the classification of triglycerides into fats and oils. Okay. Finally, a few words on the biological functions of lipids. See, lipids are very important biomolecule having a lot of functions. Biological role or functions of lipids. Citing a few examples, number one, lipids are a good energy reservoir of animals, especially animals. See, generally we know that we take in carbohydrate for our regular energy requirement, but when we are fasting, for example, our body will make use of the energy derived from the lipids for the energy requirement. So lipids form an important energy reservoir for animals. Number two is that lipids act as heat insulator, protect our body from temperature changes. So heat insulator and also shock absorber for organisms. Number three, the phospholipids, which act as an important structural component of cell wall. Right? Phospholipids, we will discuss in detail about their role in cell membrane, cell wall. And the fourth one is waxes, another important class of these lipids. Waxes are very important and they act as protective coating for animals and plants, and they prevent loss of water from the plants, etc. There are a lot of importance for waxes, and you know this wax we discussed earlier. For example, myricil palmitate, which is a wax produced by bees, is a beeswax, and that they use for making honeycomb, and it has a lot of applications. Waxes are used in making polish, etc. Many applications are there. And another important application, biological function, is vitamins, especially fat soluble vitamins like vitamin A, D, E, K, and also steroid hormones are important, essential for our body. Then another importance is that lipids act as cellular metabolic regulators in our body. They regulate a lot of metabolic activities taking place in our body. Okay, so in that sense, lipids are a very important biological biomolecule having a lot of functions in our body, in plants as well as animals. In the next class, we'll discuss in detail about two important classes of lipids, that is wax as well as phospholipids and also steroids, etc. in coming classes. Thank you.